Linear versus nonlinear. So you have placed a bunch of equations into your document, and you should now see that y equals x, when you put that in Desmos, that was a linear function. Y equals x squared minus 1 was a nonlinear, made a U shape. Y equals 3 to the x plus 2 made an L shape, or maybe it went up this way actually. Y equals 6x minus 5 makes a line. Y equals 6 over x did this really cool like double line thing. Kind of went like this. Y equals negative 1/2 x squared plus 2. That again also makes an upside down U shape. Y equals 1/5 x plus 3 is linear. Y equals square root of x minus 2 is nonlinear. Y equals 2 was a line. Even though there's no x involved, it's still a function with an input and output. X plus y equals 2 was also a function, a linear function. X equals 3 is a linear function. And last but not least, y equals 3x to the third plus 3. I know it's sloppy handwriting, but it was also nonlinear. Okay, so these are your linear and nonlinear sorts. You can check your answers. Pause the video if you need to. But I want you to really concentrate on the linear side. Look at what they almost all, have in common. Concentrate on the x for a moment. The x's, it looks like they don't have an exponent, but they do. You just don't see it. It's an exponent of 1. Really, there's a little 1 here, and here, and here. X to the first power. Now, I know you might look at the nonlinear side and say, well, Mrs. Evans, where there's the square root of x, that has an exponent of 1. Yes, but you're taking the square root of x, so it's nonlinear. You're operating on it with a square root symbol. Whereas on the linear side, x is just free to be himself. Then you might look at y equals 3 to the x power and say, well, that has an x to the power of 1. No, it doesn't. X is the power to 3. Okay, so that doesn't count. When x is the power, that is also nonlinear. Well, Mrs. Evans, then what about when the x here had an exponent of 1? Yes, it does. But just like with undefined, when it's anything a 0 or an x is in the denominator, it's a problem. So you can have y equals x, oh dear. Y equals x over 6, and that's linear. But as soon as the x is in the denominator, that's a no-no, just like undefined. Okay, y equals negative 1/2 x squared. Here you see the exponent is not 1. Here it's not 1. Here it's not 1. So when the exponent is not 1, it is nonlinear. When the exponent is 1, it's linear. Okay, so let me pause and I'll briefly switch back to your guided notes. Okay, so let's take those rules that we just developed and put our notes together. So a linear function in a graph makes a straight line. L-I-N-E. I know that doesn't look like an L. X does not have an exponent, but I want to make a little asterisk here that you see. It does have an exponent. You just don't see it. I don't want you to go to high school next year and your new teachers say, they taught you there was no exponent? Because that's not true. There is an exponent. It's just an exponent of 1, and so they don't write it. And it also has a constant rate of change. So here, how does this look on the graph? Well, it looks like a line. Here, the table has a constant rate of change. So we can go 1, 2, 3, 4, 3, 6, 9, 12. And this is a plus 1, plus 1, plus 1, plus 3, plus 3, plus 3. Looks good, right? Constant rate of change. Examples, y equals x, or y equals 2x plus 5, or y equals x over 6. Those are all good examples. All right, how about the nonlinear side? The nonlinear side, the graph is not a straight line, so like a U shape. Or it has an exponent of like 2 or 3, or is in the denominator of a fraction. And it does not have a constant rate of change. So for example, you might have 1, 2, 3, 4. So it's all going up plus 1, plus 1, plus 1. But then you might have 3, and then 6, and then 8, and then 20. And that's plus 3, plus 2, plus 12. That is not a constant rate of change. So examples of nonlinear functions: y equals x squared plus 16, or y equals 6 over x with x in the denominator, or y equals, let's say, square root of x. These are all nonlinear examples. Okay, I know I went through that fast. You can always rewind the video, go back, pause the video, and check your work. You got this.